Hey everyone, this is part two. So we're going to start off with watching out for bias. So we're going to start with an example. So suppose you want to determine the average height and weight of male students at a large university by measuring the heights and weights of a sample of 100 students. Would a sample consisting of only football players be representative of the population with respect to weight? So, if you've ever seen football players, they're usually some pretty big guys. So, no, it wouldn't be. Because football players are larger. Right? So, this is what bias is. This study, in this case, would be biased towards football players who are larger. So it would end up with results that are much larger than the average student. Okay? So a statistical study suffers from bias if its design or conduct tends to favor certain results. A researcher could be biased if he or she has a personal stake in the outcome of a study. So why would television networks use Nielsen to measure ratings rather than doing it themselves? So imagine that you're the one who gets to decide ratings for shows. Well, what would you give the highest ratings to? Your favorite show. So one person getting to decide, well, that would just make them biased towards whatever shows they like. It may not represent the population as a whole, right? So they would be biased towards their favorite shows. All right, next up we're going to talk about the types of statistical studies. So observational studies are ones where you're just observing the sample to see what they do. So for example, in Nielsen studies of television viewing, they're designed to observe the television viewing behavior of the 5,000 homes. Experiments, on the other hand, are you're specifically trying something out. So like in a medical study designed to test whether a large dose of vitamin C can help prevent colds, the researchers must ask some people in the sample to take large doses of vitamin C. So they're actually trying something out rather than just passively observing what is already happening. Right? To determine whether an experimental treatment worked, you must compare groups that receive the treatment to those who don't. A treatment group is the group of sample members who receive the treatment being tested. The control group is the group of sample members who do not receive the treatment being tested. So the control is always just the people who don't receive the experiment, just to be able to use something as a basis for what's normal. Right? And just as a note, it is very important for the treatment and control groups to be selected randomly and to be alike in all respects, except for the treatment, right? Because you don't want something skewing your results if the two groups weren't alike to begin with. You want them to be completely the same, as close as you can. That way you can tell if one group changes and one doesn't. And next up is the placebo effect and blinding. So people can be affected by their beliefs as well as real treatment. So the placebo effect refers to the situation in which patients improve simply because they believe they are receiving a useful treatment. All right, so it means that the control group might change if they think that they're getting a treatment. Even though they're not actually getting any kind of treatment, it might change a bit just because they think they are getting treated. All right? So, people in the control group are given a placebo. In this case, it's pills that look like vitamin C pills but don't actually contain vitamin C. Right? So, as long as the participants don't know whether they're in the treatment group or the control group, then anything that's psychological that's affecting the groups should affect both groups because they both think they're getting treated. So, in that regard, they're still the same. If one group thought they're getting treatment and one group knows they're not, then that could skew things a bit. The practice of keeping people in the dark about who's in the treatment group and who's in the control group is called blinding. So it just means that they don't know who's who. So you don't know if the pill that you're being given is actually treatment or if it is vitamin or if it's a placebo. So you're completely in the dark about which group you're in. So an experiment is single blind if the participants do not know whether they're members of the treatment group or members of the control group, but the experimenters do know. All right, so whoever's doing the study, they know who's who, but the people in the experiment don't. Whereas an experiment's double blind if neither the participants nor the experimenters know who belongs to which group. All right, so that means both the people getting tested on and the testers themselves are completely in the dark as to who is who. Now, just one note about that is at the end of the experiment, you do have to know who was who in the study. So instead of just knowing themselves, just a little extra bit here, since somebody needs to keep track of it, what they'll usually do is they'll hire somebody else to keep track of who is in which group. All right, so the people actually doing the experiment don't know until the very end, and then the people who they hired will tell them, that way they can actually go ahead and get their data from that. All right. And with that, that takes care of all of the fundamentals, all of the basic vocabulary, and everything that you'll need to know going forward. So that is it for this set of notes.